students. Today I am going to show you a 7 to 8 minutes video. A very small videos I am going to generate now onwards, okay, and put it online on Facebook and Instagram as well. About AAHL and AIHL mathematics, okay. So today this video explains you how to find Maclaurin series expansion for any function in just 3 steps. Okay then. So look here. The Maclaurin series formula is this. F of 0. Remember that this is without derivative f0. Whatever is the function, find it at 0. Then x into f dash of 0 first derivative plus x square by factorial 2 into f double dash of 0 plus x cube over factorial 3 into f triple dash of 0 and so on. All this can be summarized by this sigma notation. K is equal to 0 to infinity. Upper limit is infinity, okay? Fk of 0, x to the power k over k factorial. Now remember one thing. Only this part we are going to find in 3 steps. X to the power k and k factorial is by default by the formula, okay, and then second part will be nth degree Maclaurin polynomial approximation we have to find. So if it is nth degree, then mn of x will be represented by k is equal to 0 to n. So look here, lower limit is same as k is equal to 0, but upper limit is not infinity, it will be n, where n is the nth degree Maclaurin polynomial. Okay, everything else remains the same. So this is the first step, but the function is f of x is equal to 1 upon 2 plus x, and then fourth order Maclaurin polynomial we have to find for this function. So f of 0 is 1 over 2 plus x. I'll get it up and it will be 2 plus x to the power negative 1. Then I'll find first derivative. So for that I'll bring power to the left. So minus 1 into 2 plus x to the power negative 2, because we subtract 1 from the power. I hope you know all this. And that can be written as a pattern here. So why like that I'm writing? So that I can write a general rule or general formula or general pattern for the nth order derivative or kth order derivative. So minus 1 is 1 time, so minus 1 to the power 1. And then this number 1 is multiplied, so 1 factorial. Power negative 2 remains as it is. Then second order derivative I'll find. So for that I'll bring power negative 2 to the left, and from power subtract 1. So it will be negative 3. As a pattern I write it like this. Why? Because minus 1 is twice, or minus sign is twice. So minus 1 to the power 2. And there are numbers 1 into 2. So that I will represent by 2 factorial. And bracket to the power 3 as it is. Then third order derivative. For that I'll bring minus 3 to the left. So now I have minus 1 into minus 2 into minus 3. And from power I will subtract 1. So it will be negative 4. Now I have 3 negative signs. So minus 1 to the power 3. And I have 3 factors, 1 into 2 into 3. So I'll represent it by 3 factorial. The bracket to the power negative 4 remains as it is. So if you continue like this, then kth order derivative will be, from this you can write this one, minus 1 to the power k, replace 3 by k, k factorial, replace 3 by k factorial, and the bracket to the power will be negative 1 more than the order of the derivative. See here, observe here, observe here. Everywhere the power of the bracket is 1 more than the order of the derivative but with negative sign. So kth order derivative will have one more, which is k plus 1 but with negative sign. So I hope you understood. This was the first step. Now let us go to the second step, where we have to find derivative at x is equal to 0. So what we did in the first step, I am writing it here again, and I am replacing x by 0. So first I'll replace x by 0 in the given function. 0 here, 0 here. 2 to the power negative 1 will be 1 over 2. Then f dash of 0 and 0 will give him f dash of 0 minus 1 to the power 1, 1 factorial. And this 2 to the power negative 2 will go in the denominator, which will be 2 square. Then second order derivative, I'll replace x by 0 here, x by 0 here, and I'll get all this. I hope you understand. Minus 1 to the power 2, 2 factorial, and 2 to the power negative 3 will go in the denominator, 2 cube. Then third order derivative at 0 will be 0 here, 0 here. So I get negative 1 to the power 3, 3 factorial, and 2 to the power negative 4, which will be in the denominator 2 to the power 4. So on, if I continue, again the same pattern I can write like this. Fk of 0 minus 1 to the power k. See, 3 will become k. K factorial will become 3 factorial will become k factorial. And the denominator 2 to the power 4 is one more than the order of the derivative. So for kth order derivative, it will be 2 to the power k plus 1. So I hope you understood second step. Now, third step is substitute all these derivatives at 0 into the formula. The formula is this. So f0 of 1, f of 0 is 1 by 2, which we will replace as a first term. Then the other derivatives we can represent by the sigma notation. I did not want to write all those steps again and again. So look here, all these are represented by the sigma notation. But remember that it is starting from 0 to infinity, including f of 0. Okay, always like that. But here I am writing f of x is equal to 1 by 2 separate because it was f of 0. And this I am putting it here because my answer was this fk of 0. I have put it here just for your reference. Okay. So same I am writing here, as I said earlier, that f of fk of 0 will be replaced by this thing. Okay. But x to the power k and divided by k factorial will be by the formula. So that is extra part we are putting. From this k factorial gets cancelled, and we are having, this is the simplified form. Now if you take this first term inside, which is f of 0, so always remember k will be replaced by 0. Whatever is your answer here, it will be included in the sigma notation, and 1 will be replaced by 0. So this is our final answer. So I hope you understood this. Now B part says find the fourth order Maclaurin approximation. As I told you, the formula for the fourth order Maclaurin polynomial, look here, I wrote it here in the beginning, Mn of 4. See here, this formula I'll copy there, and in this we are going to replace fourth order Maclaurin polynomial. Sorry. So see here, this was the formula. So in this formula, I am going to replace n by 4. So look here, n by 4. Same thing, but simplified form. Fk of 0 is this one. Okay. So I am replacing upper limit n by 0. Now, to simplify it, replace k by 0, you get first term. K by 1, you get second term. In this, we are replacing. K by 2, third term. K by 3, fourth term. K by 4, fifth term. I hope you understand this. This is very simple. Replacing k by 1, 1, 1. K by 2, 2, 2. K by 3, 3, 3. And the last term k by 4, 4, 4. So I'm getting all these terms. The simplified form is this. Now we have to find f4 of 1. So replace x by 1 everywhere and you get all these coefficients only, which when added together is 11 by 32. With this, I end this lesson. I hope you understood this. This is very simple, really. Now, the PDF of this explanation, this lesson, you will find in the link given in the description. Okay. So I'll erase this or I'll put a round around it so that you are not confused. This I'm using here. Okay. Okay then. Bye for now.